Okay. Hello, everybody. I'm Paul Morie. I work on Kubernetes at Red Hat, and I lead the engineering effort around Open Service Broker API and Service Catalog at Red Hat.
Todd Sanders, work on the systems design and engineering team. Amongst other things, my group is focused on the Ansible Service Broker, which we're going to talk about today.
Hi, I'm John Matthews. I'm the tech lead for the Ansible Service Broker.
Where's the clicker? Oh, there we go. Okay. Can I just get a quick show of hands? Like, raise your hand if you've ever met a projector that you fully trust. I don't see any hands going up, but that's not what we're here to talk about. So this talk is about enabling microservices in the enterprise. So it's probably best if we start talking about what the barriers are. So there's basically two different classes of barriers. There's fragmentation along how different resources are provisioned and how information about credentials and coordinates and configuration that you need to use those is shared. And then also, there's different schemes for doing this on different platforms. And in fact, there might even be different schemes on the same platform in different orgs. And what it amounts to is, like, as a developer operations person or someone that's in like a role that's a combination between the two, you wind up, I know it sounds crazy, but you wind up filing a lot of tickets, doing a lot of different processes. It fragments your attention, all kinds of stuff. So we need some way to mitigate this, all these different factors. And the good news is that we have a pretty good way. There's a thing called the Open Service Broker API. And it's the successor to the Cloud Foundry Service Broker API. Can I just get a quick show of hands in the room? How many people have heard of the Service Broker API before? Okay, so there's some level of familiarity with that. The driver for creating the Open Service Broker API is that people started coming to Cloud Foundry a couple years ago and indicating that they wanted to be able to use that same kind of model to consume services in platforms other than Cloud Foundry. So we formed an API working group we sort of bootstrapped the Open Service Broker API working group in September of 2016, and it was officially announced in December 2016. Besides Red Hat, there are a number of different industry leaders that are present on the working group, like Google, Pivotal, IBM, Fujitsu, and SAP. And the best part about all of this is that there's an existing ecosystem that comes with this API as we adopt it. So sounds pretty good, but it's important to understand the mechanics, and they're pretty simple before we go further. So when we talk about a service broker is basically some entity that manages a set of capabilities that are called services. Now, since we're going to be saying service a lot, I want everybody to take note. In the upper right-hand corner, there's this little like whirling vortex, and that's actually the logo for the Open Service Broker API. That logo is going to change as we change context. And unfortunately, there are just a lot of naming collisions in this problem space because services are everywhere, right? But when we talk about service in the context of Open Service Broker API, it's basically a class or capability. Services also have at least one plan. They can have many plans, and a plan is basically a tier of that service. So as an example, a service that a broker offers might be a database as a service. And the different plans might start out with maybe you've got a dedicated table space in a multi-tenant database that already exists, going up to you get a really beefy dedicated database with like 16 cores and 50 gigs of RAM or something like that. When we want to use one of these capabilities, we provision a new service instance out of it. So continuing our database as a service metaphor, that would mean that you've got an actual database that you can get your hands on and use. And having them is great, using them is even better. So there's a notion of a thing called a binding, which represents a relationship between a service instance and an application that uses it. So continuing our database metaphor, a binding might represent credentials that were created in your database for an app like a guest book to use that gets injected into that app. So now that we've got the ground set about what all this stuff means, let's talk about how do we integrate with this in the Kubernetes ecosystem. That's where the Kubernetes service catalog comes in. And about the same time that we started having the API working group discussions around Open Service Broker, we also created a new special interest group in the Kubernetes community around service catalog. In October 2016, we also created a new incubator repo in the Kubernetes incubator organization. And we've got about 27 different contributors right now from Red Hat, Deis, which was recently acquired by Microsoft, Google, IBM, and some other organizations. We're doing weekly releases right now on an alpha version. And it's our hope in the next 2 to 3 weeks that we'll be able to take the Service Catalog API to beta and start doing beta releases. So let's talk about what that API looks like. It's pretty simple. There are just a few different resources that correspond to the nouns that we've already discussed in the context of Open Service Broker. And by the way, note our little whirling vortex of openness has turned into the Kubernetes wheel. So the first resource that we'll talk about is, surprise, surprise, it's the broker. And what the broker resource looks like is basically a URL that you can talk to the broker and an optional reference to a secret that holds auth information. Now, in order to consume a particular broker in the catalog, and you can consume many, there's no upper limit, the cluster operator creates a broker resource, and the catalog is responsible for talking to that broker, getting its lists of services, and transforming them into this service class resource, which, since we have that inconvenient name collision thing again, we can't quite call them services, so we call them service class, since they are similar in nature to the storage class API resource, which represents a storage capability. Now, the service class says whether the service is bindable or not. Not all services are bindable. It has a list of the service's plans and indicates whether the plan on the service is updatable. What that means is, like, say that I start out with my multi-tenant database and I've just got a dedicated table space, and as my app grows, I need to get more and more power behind it. So it's good to have the ability to go from that, like, maybe a bronze tier to a silver and then a gold. That's what plan updatable is. So in order to provision a new instance of a service, you create an instance resource, and instance represents your intent that a service class should be provisioned into a new instance. It contains the service class and plan that you want to use, and a set of parameters that are passed to the broker when the broker does the provision. After you got an instance, you can bind to a bindable service by creating a binding resource. The binding resource has a reference to the instance to bind to, a set of parameters that are passed to the broker during the binding operation, a name of a secret in that binding's namespace to put the results of the binding into, and a thing called a pod preset template, which is really just a fancy name for a resource that describes how an application should use the results of that bind operation. So now that we know what the API looks like, we can talk a little bit about the architecture of the catalog. And this will be pretty familiar to those of you that have some background with Kubernetes. Can I do another show of hands? I love them hands. How many people are familiar with the API server controller architecture that's used in Kubernetes? Okay, so one or two. So this will look familiar to you, but maybe I'll go into a little bit more detail than I had planned so that it's accessible to everybody. So there's a few different entities in the patterns that we use in Kubernetes. The first one that we're going to talk about is the API server, and it's responsible for presenting a REST interface to be able to work with the different API resources that we described. We've built a separate API server outside of the main Kubernetes API server, which is a pattern that we expect to be the dominant way to extend Kubernetes in a first-class way. So we've got a special catalog API server that has an API group that contains the resources we talked about. And that's basically just supposed to be a data store and an endpoint that we can use to work with those resources. To actually implement the business logic in the service catalog, there's a process called the service catalog controller that is watching that API server and responding to events when a new resource is created or when it's updated. So the catalog controller is also responsible for talking between the thing that we call Kubernetes Service Catalog and the brokers that it uses. So going back to the examples that we talked through for the different API resources, when I want to add a broker as a cluster operator, I make a new broker resource. The catalog API server sends a watch event that the controller picks up. Controller goes, talks to the broker's endpoint, pulls down the list of services, transforms it into the service class resource, and puts it back in the catalog API server. Now later on as a user, when I want to provision a new resource, provision a new instance of a service, I make an instance resource, create it in the catalog API server. The controller picks up a watch event, goes and talks to the broker and says, hey, provision this new instance of this service with this plan, with these parameters, and is responsible for completing that flow with the broker and updating the status on the instance. Same thing for binding. You make a binding resource, controller picks it up, talks to the broker. Pretty simple, right? You'll notice also that the Kubernetes API server is also on this diagram. The service catalog controller needs to talk to that to manifest the result of a binding into the user's namespace that creates the binding. So I thought I deleted this slide. I'm a little surprised to see it, but that's okay. We've done a lot of console enhancements, which if you saw Jim's keynote earlier today, and you have prior experience with OPENSHIFT, you may have noticed there's a new landing page which allows you to browse the catalog services, search them, and you'll see on this that there are a number of different AWS services, just like we showed in the keynote earlier today. Now on the overview page, you can also now see provision services and bindings that you've made to your applications. You can unbind, you can make new bindings, you can deprovision from here too. So that's kind of the user-facing portion of it. The back-end pieces are numerous. We've got a lot of different integrations that we're doing. So we have brokers in progress for OPENSHIFT templates, where you'll be able to point the template broker at a set of OPENSHIFT projects and pull in those templates and expose them through the service catalog. We've also got an ANSIBLE broker in progress, which I hear that ANSIBLE is sort of popular these days. So we're going to talk a little bit more about that later in this presentation. John and Todd are going to do a deep dive on that. And then we've also got a messaging as a service broker that uses the en masse provisioning API to provide message queues, topics, and message routers as services. So this sounds good, but we also need a way for all of you to expose your services through the catalog. There's kind of a continuum of options. The most simple one is if you can express what you need to do in an OPENSHIFT template, you can write an OPENSHIFT template, point the template broker at the project that template lives in, and it'll just show up in the catalog. If you need some more power, or you want to leverage your existing Ansible investment, you can write an Ansible playbook bundle, which we're also going to hear a lot more about later on. And if you need full control, you want to write some Golang code, we've got a broker SDK in progress that our goal is to get you to a point where the experience is like you clone the repo, you type make, you've got an empty broker that implements the spec. You can write a metadata file that describes the services that the broker provides and write Golang code for your provisioning and binding business logic. So at this point, I'm going to hand it off to Todd, and we're going to learn some more about how to leverage Ansible.
Okay. Thanks, Paul. All right, so following on with Paul, I'll make you raise your hands again. So how many folks here leverage Ansible in some shape or form in their existing environment? All right, so great. So we'll talk a little bit about sort of our implementation or an implementation of the Open Service Broker API that we call the Ansible Service Broker, which really can take advantage of that investment. It's designed to allow us to define and orchestrate delivery of simple to complex services or applications onto OpenShift using Ansible. As we dig down into this, we're really going to talk about two things in our architecture. We're going to talk about the broker itself, and again, this is an implementation of this Open Service Broker API that Paul talked us through. It's going to allow us to support sort of traditional source-to-image deployments or make use of existing images as they may exist in your repositories. The other thing we're going to talk about is sort of the fuel to that broker, and this is where we call it an Ansible Playbook bundle. Essentially, this is the definition of your service or application. It's a fairly lightweight application definition, simply a directory of playbooks, if you will, and we'll talk through this in depth. The important thing to note here is, and we'll show this in the next slide, is we also refer to this thing called a meta container. So we take up this directory of playbooks, we bundle it up inside a container image with an Ansible execution environment. That allows us to kind of fire that up and run playbooks that talk to services within OpenShift to realize your application in that environment. So picture may help. So we'll start at the top here in the middle. There's a box called Red Hat Container Catalog. It shows Container Catalog here. It really be any image registry that you have. The Ansible Playbook bundles, or what we call APBs for short, are again these meta containers that contain this grouping of playbooks. The Ansible Service Broker is going to essentially discover these APBs and make those available to the service catalog, thus showing services or applications in the UI. So then the service consumer can come along and browse and say, hey, I need a database, very similar to what you saw, sort of if you saw the keynote this morning, looking for a database service out on Amazon. And I can click on that, and when I do that, that message goes to the Ansible Service Broker. Broker finds the appropriate APB container image, fires that up, and runs the playbook, thus causing services to be deployed into OpenShift. So in a simple nutshell, that's how that works. I know I talked through that sort of fast. John's going to walk through an example for you, so you'll see that sort of in action. If we dig a little deeper into this thing called an Ansible Playbook bundle, again, like I said, it's really, really lightweight. We wanted it to be that way, so these are really simple and easy to create. You're going to see sort of 4 playbooks here that correspond to the lifecycle actions that are part of the Open Service Broker API. So these are things like provision, deprovision, bind, and unbind. And they map to exactly what you want to do for your service or your application on that particular event. The other piece you're going to see here is something called an APB.YAML, and really that's just metadata that's used by the service broker, or the Ansible service broker, to drive this process. So we're going to take a look exactly into that file and what's there, but included in that file would be a reference to the actual APB image so that I can fire up that image with the Ansible execution environment in it and run the particular playbook. It's also going to expose a number of type parameters. And these parameters are parameters that will get exposed through the Service Catalog UI so that at deploy time or at provision time, the end user has some configuration over that service. Also should note, I guess, that on the right-hand side here, you're going to see deployment role. You can use any roles that you may have, or maybe roles that you have in Galaxy that are already created. You could certainly take advantage of those as part of this as well. So if we really just kind of look at the bare basic steps here around walking through sort of a simple text-based exercise on creating an APB, this is as simple as it gets. So you're going to create an APB.YAML, which is this metadata file. You're going to create some playbooks or reference playbooks that may already exist. You're going to run a command that we have called APB prepare, which is going to bundle up those playbooks into a container image with that Ansible execution environment. You're going to put that in a registry and you're ready to go. So let's again walk down through this a little bit. So apb.yaml, if you're looking at this, again, the two pieces of information here that I want you to take note of are, number one, there's obviously references for launching this APB, because the service broker is going to have to spin it up temporarily to actually cause this playbook to run. And then you're going to see these parameters that I'm talking about. So two parameters defined here, namespace and message, that again will be visible in the UI when you launch or provision this particular service. So we'll take a look at the playbooks. So again, these correspond to lifecycle actions that the Open Service Broker API defines. So provision.yaml. So if we look at this, and I think the thing that I really want you to focus in here is most folks are used to running OC commands if you're used to OpenShift. So if you look at the two tasks here, it's really just as simple as those OC commands are directly here listed as tasks. So for example, the first one here is I'm going to create a namespace. The namespace parameter that's passed in is a parameter that's defined in apb.yaml, and again will come from the end user as a UI input. And then the second step here is I'm going to go ahead and create my sample app, the sample app being a defined resource file. Similarly, deprovision kind of follows suit. So again, I've got an OC command that's going to get run here to actually delete that project and clean things up at the end. The Docker file itself, again, this is all about what's sort of put in place that allows us to package up your set of playbooks inside a container image with the appropriate Ansible execution environment. Last thing I wanted to point out here before I turn it over to John and we get into the interesting demo is if you see on the left here, and what I've talked about thus far is just embedded OC commands. One of the things that we're working on with Ansible 2.4 is a set of upstream Kubernetes and OpenShift Ansible modules. This obviously is going to allow us to take advantage of a little bit more of the power of Ansible. So you can see on the right here, it's just sort of a comparison of if I was to use direct OC commands or if I was to embed those modules. Obviously, it's fairly similar in terms of sort of the code that's in place, but obviously there's a whole lot more power with the Ansible module. I've also added a link down here at the bottom that kind of points to that GitHub repo. I think these slides will be available for everybody afterwards. But that'll allow you to actually go take a look and see what's going on in that space around developing these modules. So just wanted to point you at that. So with that, we'll get to the interesting part, and we'll let John come up here, who's our lead engineer on the Ansible Service Broker project, and he's going to walk us through a little bit of a demo. It's not exactly what he was intending to go through because obviously we had a display problem, but we're gonna make the best of it.
Yep.
Thanks, John.
Thanks, Todd. So as Paul mentioned earlier, if you saw Jim's keynote this morning, the integration with Amazon services, that was powered through the service catalog. So you saw with a few clicks, we were able to provision and bind an Amazon database to a Python web application. So what we'd like to do now is we want to do something a little bit similar, but dive more into it to give you more of a feel of what's going on with that. As Todd mentioned, this is going to go a little bit different because I'm on the third backup laptop right now. So if you would just bear with me. So what we are going to do here is we're going to provision a Python web application, and we're also going to provision a database, and we're going to bind them together. So the first thing that will happen is we'll talk to the service catalog, and we'll find our Postgres database. That Postgres database is powered by an APB. In this case, it is the Postgres demo APB. So the first thing that we'll do is we'll download that. So the Ansible Service Broker will talk to the registry, and we'll download that APB. Once we have that APB, we have to execute it. And when we execute that, as Todd mentioned, that's really just a lightweight meta container is the term that we're calling it. Think of it as a container that runs for a few minutes and then it dies. The whole point of it is to orchestrate the deployment of our application. So in this case, when we're doing a provision, we're going to run a playbook, the provision.yaml. So it's provision playbook. When that finishes, we're going to have our Postgres service up. So at this point, just think that we have Postgres up. The next thing we have to do is get our web app. For the web app, Steve wrote a web app for us that's going to map some of the US zip code attendees for the summit. So we're going to use that, and we're going to build it through source image. So what we have right now are two things that are not connected. So we have a Python web app with no data in it at all. And what we want to do is we want to connect that web app to the database. And we're going to do that through bind. So the service catalog will bind those two for us, and that's how they're going to connect. And just a quick recap on bind, when Paul was talking about it. When you hear bind, just think of credentials. So what we're really trying to do is we're trying to get the credentials for the database into our Python web app. This way they can talk to each other. And that's going to go through with a secret. So with that, let's bring this up. Okay, so this is the Python web app that we'll end up using. Just making sure I can get to it. All right, so the first thing we do is we're going to go into the service catalog. And what we want to look for here is we want to look to see if we have a Postgres database instance, which we see down here. And we want to provision that. So I will create a new project. And we call this one Demo 2. Okay, now that I have my project up, I want to provision that database into it. So I'll go with the default plan, and just make sure I'm going into the right project. And that kicked that APB off. So what's happening right now is the Ansible Service Broker is downloading that APB image, and then it's going to open it up, and it's going to run it. The timing's a little bit weird in this, so I'll probably need about 3 minutes to finish it. I'm going to also bring up the Python app now just to make it a little bit quicker. So I'm going to go back to the service catalog, and then I'll provision the Python app as well. So what we have here is we have source image running to build our Python web application, and we have a database that's still provisioning. So let me show you what's happening with that APB. And I apologize, this is not as smooth as I planned, but I think I can still get some of the data to show you. What I really wanted to show you right now was the APB actually running, so you can get a feel of what's happening. Okay. So what you're seeing is this is the Postgres demo APB running. And for those of you that are familiar with Ansible, this is really just the output of an Ansible playbook that's running. So you see that we created a namespace, volumes created, a service, and so forth. This is probably going to take on the order of about a minute to complete. Let's just give it a little bit more time to come up. One other thing that we've done with this, since it is Ansible, there's other things that we can do besides just bringing this up. So we decided to make the demo a little bit quicker and seed some other data here. So you'll see after the database is up, we put some other things in here to seed some of the US zip codes. And this is almost done. Yep. So the last thing that I want to call out is you'll see here there's some bind credentials. And that bind credentials, those are the secrets that are going to allow us to actually go ahead and talk to the database. So I'm going to go back to our Demo 2 project and see if our Python app is up. Just give it a second, see if it's coming up. So the build's still ongoing there. So probably about 15 seconds or so, we should be good. And see if it's up yet. Okay. So this is what we wanted to see at this stage. What you're seeing right now is a Python web application with no data, so it's pretty boring. What we want to do is we want to connect this application to the database so we can see the zip codes of the US attendees. So the way we'll do that is we'll go back to the console, and then we're going to click on the kebab menu for the Python application. And then we'll click on Create Binding, and I want to bind this Python application to the Postgres database. So I see our Postgres database is selected, and then I'll click on Bind. And the bind has completed. Now, if you notice here, you see that now we're on the second deployment. So what happened, the service catalog created a secret to hold those credentials, and then injected that secret into our pod, and it created a new deployment. And that's what's running right now. So let's just take a look at the secret so you can get a feel of what was in there. So you can see this is all the standard things you would expect if you want to connect to your Postgres database. So when we did the binds, we got the secret, and that got injected. And then the last thing is just to look to see if we have data now. Good. So now you can see this is what it looks like when we have the data. So let me go back to the slides for a minute. Sorry, the slides got a little bit out of order. What I wanted to highlight here is that this Postgres database, this is one of those good examples that talks to some of the newer modules that Todd was mentioning. So these are using newer Kubernetes and OpenShift Ansible modules that will be in Ansible 2.4. So if that interests you, I'd say this is a good one to take a look at. We also have a number of other examples that are out on GitHub right now. So if you go to fuser/apb-examples, you'll see examples there for WordPress, for ManageIQ. We also have RDS from the demo early this morning. And we'll be adding other examples over the next few weeks. At this point, that concludes what we want to show you for the demonstration. So I'll turn back over to Paul.
So there's so much information that we skipped the standard additional information slide. And we've got a goo.gl URL that will take you to a Git repo that has a bunch of links. So I want to just take a second and thank everybody in the Kubernetes community and at Red Hat that has been working on this. Just fantastic group of folks, and thank all of you for coming today. So if you have any questions, we've got some time to field anything you want to ask as pertains to the catalog. Yeah. In a move that surprises no one, an engineering manager at Red Hat has asked when she will be able to try it out. Very good question, Tracy. In fact, we're shooting for a tech preview level in OpenShift 3.6 with GA hopefully in OpenShift 3.7.
And will the Ansible stuff be part of that?
Absolutely. The question was, will the Ansible stuff be part of it? And the answer is absolutely. So I think in the GA release that everything will, as far as I understand, go through the catalog, but it shouldn't be a drastically different experience at all compared to what you see in online or OCP today. OC commands, the question is, will there be OC commands? Do you mean to work with the resources like you would another Kubernetes resource? Really good question. So in fact, yeah, there will be. And one of the things that we didn't go into detail just due to time is that the API server for catalog is going to be aggregated with the normal API server. So as an end user, you don't have to know the difference between them. They work just like a normal API. The API aggregator presents a unified discovery endpoint that will just show you all the APIs that it presents. And there will probably be some porcelain commands too for something like OC create binding, stuff like that. That's a really good question. So the question is for messaging as a service, is it modeled as a template or basically how's it represented? So for messaging as a service, that's actually one where they chose to write custom code because they're using an API that's easier to program to than it is to use one of the other mechanisms that we touched on. The question is, how does it interact with pipelines? Can I ask for a little bit more detail? When you say interact with pipelines, do you mean a pipeline that might be deployed by a service catalog service? Gotcha. So I think there are a few different components of the question. Let me try to break them apart and answer them one by one. And if you guys have any input, feel free to shout out. So I think the first question is, can you deploy a service via the catalog that uses a pipeline? The answer to that is yes. So the stuff that Todd and John show is basically just making OpenShift API resources. And since everything is basically an API resource, you could have a template that created the necessary resources to create a pipeline. I think the next one The next facet is there a way to do an upgrade of a version of a deployed service? Is that accurate? Yeah, so that is a gap that we currently don't have a good representation for in the API. It's actually, I believe there's an issue that's been created to add one, and we expect that that's something that people will want to do as a first-class thing of take me from Postgres X to Postgres Y. So the question is, will there be a way to model upfront the dependencies that the application needs, right? That's a really, really good question, and I'll just call out that what you're asking about sounds similar to what we have for dynamic provisioning for storage, where you might want to just say, I need to use this thing, but I don't necessarily know where it comes from. There's a really high degree of interest about this use case in the Kubernetes catalog SIG. We're probably not going to have that immediately, but it's definitely on the table. I would love for anybody in this room or that might be watching later on that's interested in that to come and join the catalog SIG, and we can all talk about it together and build something everybody likes.
Yeah, I think to follow on there, one of the things we did not show here that we've been discussing is in that actual APB, eventually there will probably be dependency information so that you can see this particular application has dependencies on these services, so we'll at least know that and be able to enunciate that to the end user.
That's the result of the binding. So when the broker gets a request to do the binding, it's the broker's responsibility to generate those, or maybe the broker has something in its state that says what it's supposed to hand back. It's probably more likely that they get generated, and the payload that we saw when John was doing the demo contains that information that we later saw in the console that went into the Kubernetes secret. Does that make things more clear? Very good question. So I touched on this mechanism called the pod preset template. Pod preset is a new resource in Kubernetes 1.6. And basically a pod preset says, this is who should get injected with this thing, where the who is specified by a label selector. And this is how they should get injected with it. So there are, part of the pod preset is like a subset of the pod spec, where you could specify environment variables. There's a new mechanism in Kubernetes 1.6 that instead of specifying environment variables for each secret key you want to inject, you can just say, give me everything that's an environment variable in this secret. And then you can also use a secret volume. So you can specify volumes and volume mounts. And the way that this works with your application is, as your pods are created, the matching pod presets for your pod's labels mutate the pod spec as it's created. And there will be, in the future, integration with the deployment trigger mechanism so that when you create a new pod preset that matches a set of pods that are deployed, there will be an upgrade, or I'm sorry, like a rolling update that happens and refreshes your app. Correct. So just to put a little bit more detail on it, the catalog controller will create from this pod preset template a new pod preset when the binding happens successfully. So it'll create a secret, it'll create the pod preset from the template, and once the triggering mechanism is in place with deployments, your deployments will just automatically roll out a new generation of pods that are mutated according to the pod preset. So, yeah, it sounds like we're about out of time. Thank you, everybody, for coming. Hey, give a round of applause to this guy. He did a live demo on his third backup hardware, and it worked.